Mobile telephone system. Mobile telephone systems can be split into three generations. First generation, or 1G mobile phones, focused on analog voice. This system used one large transmitter on top of a tall building and only used one channel for both sending and receiving. The user had to push a button to enable the transmitter and disable the receiver, so you can kind of imagine a walkie-talkie. These were called push-to-talk systems and are commonly used in CB radios, taxis, and police cars. Second generation, or 2G mobile phones, made the switch from digital to analog. This gave increased capacity by allowing voice signals to be digitalized and compressed. It also improved security by allowing voice and control signals to be encrypted. This in turn deters fraud and eavesdropping, which was possible on the first generation. It was possible because anyone who had the same frequency could listen or talk on the same frequency. So once again, similar to a walkie-talkie. If two people have the same or if three people have the same walkie-talkie, then they can all hear the same conversation. Lastly, 2G phones enable new services such as text messaging. The main difference between third generation and previous generations is that this generation focuses on both digital, voice, and data. This was seen as a big deal because data traffic was already higher than voice traffic, even though it wasn't primarily focused on. This allowed users to have wireless data at much higher bandwidths than before. Digital voice and data. The benefits of digital voice and data are high quality voice transmission, messaging, which replaced email, fax, SMS, multimedia, music, videos, films, and television, and internet access, meaning you can now surf the web and you can also stream video and audio. Advanced mobile phone systems. Here are two images showing the ways that advanced mobile phone systems work. You can see in A, the frequencies aren't reused in adjacent cells. This allows for people to not overhear each other. And in picture B, it shows that to add more users, you can use smaller cells. If you look in the center, you can see that there are smaller cells than the ones around it. In all mobile phone systems, a geographic region is divided up into cells, which is why the devices are sometimes called cell phones. In AMPS, which just stands for Advanced Mobile Phone System, the cells are typically 10 to 20 kilometers across. In digital systems, the cells are much smaller. Each cell uses some set of frequencies not used by any of its neighbors. What gives cell systems more capacity than previous systems is the use of relatively small cells and the reuse of transmission frequencies in nearby but not adjacent cells. Smaller cells also meant that less power is needed, which leads to smaller and cheaper transmitters and handsets. GMS, the Global System for Mobile Communications. The figure shows that the GSM architecture is similar to the AMPS architecture, though the components have different names. The mobile itself is now divided into a handset and a removable chip, with subscriber and account information, and is called a SIM card, short for Subscriber Identity Module. It is the SIM card that activates the handset and contains the secrets that let the mobile and the network identify each other and encrypt conversations. A SIM card can be removed and plugged into a different handset to turn that handset into your mobile as far as the network is concerned. Here we can see that each TDM slot consists of a 148-bit data frame that occupies the channel for 577 microseconds, including a 30 microsecond guard time after each slot. Each data frame starts and ends with 3 0 bits for frame delineation purposes. It also contains two 57-bit information fields, each one having a control bit that indicates whether the following information field is for voice or data. Between the information fields is a 26-bit sync field that is used by the receiver to synchronize to the sender's frame boundaries. That is the end of my presentation.